Oh, okay. Yeah. As long as you keep adding it on the bottom, it'll get logged. Yeah. So that's not a problem.
Yeah. Exactly. Even whenever they release it, usually errors. Okay.
Okay, I'll make a start of the content for tonight. So, we are almost at the end of the first part of our journey with computer programming. At the moment, our first goal is to make our programs useful. And so we've been each week adding in incremental elements to do that. So we start off with output to the user. That's pretty useful. We can tell the user what's happening. We can tell them results of calculations. We can tell them hello world, whatever it might be. And then we look at variables. Now that's pretty useful because now we can store information while our program is running. And that means that we can save a little bit of processing time. We don't need to recalculate everything every time. And last week we looked at the idea of user input. So now we can take the values in from the keyboard, store them in a variable, and utilize them in a calculation, which we then can print out the results to the user. There are two more things we need before we can start doing interesting things with our programs. The first thing we need is conditional statements, or if statements, if you've looked at a program before. And the second thing we'll need, which is what's going to happen next week, is iteration, which is loops. And once you have that, once you have the ability to have conditional statements, and that is where you ask your program a question, and depending on the value of a variable, it will act in different ways depending on what you've programmed. And when we look at iteration, it's the idea of getting your program to do a task a number of times. And that number can be set by a variable, it can be set by other limits, and it means that your program can have, it allows for, I suppose, divergence in the program for when one person runs it and when another person runs it. At the moment, all of our code starts on line number 1 and runs all the way to line n. And everybody, if I run that code 100 times, it will go the exact same, 1, 2, 3, 4, 5, 6, all the way down. And what we're going to see as we start to look at conditional statements is we ask questions. And we only get into certain blocks of code now if that question is true, if we have a valid answer to that question. Next, if we look at loops, we'll see that we may run a certain block of code multiple times, depending on what value the user has entered in and how we're going to deal with it. So that's, when we finish next week, we have an awful lot of power available to our programming skills. And we can then start utilizing it to look at things where you're going to get your first assignment soonish. I can't remember what it said in the course layout, but you'll get it for that week. And it will be a program that uses variables and uses user input and uses if statements and uses loops. But at the end of it, it won't be just a little very short example like a guessing game or like enter a date and tell me what the correct, tell me if that's a valid date or not. It will be something more complete. And as we move further, as we look at the next assignment and the next assignment, and we look at additional things that we're going to add beyond our first 5 elements, we're just utilizing the 5 core elements of output, input, storage or variables, if statements and loops in different ways. We're using them in different data types. When we finish with loops, we're going to move on to something called strings, which is text. Now we've seen text so far, we put it out into our system.out.print statements, and it just prints it verbatim on the screen. But we can take that text and treat that like a variable, the same way we've been treating numerical variables. And so then we can do manipulation. We can go through that text and tell me how many times a vowel appears, how many times a consonant appears, how many spaces are in that word, how many full stops are in that word, or in that string of text. So if I can go through it and I can count the number of spaces, I can probably give a pretty good estimate of how many words are in that paragraph of text. If I can count the number of full stops, or exclamation points, or question marks, I can probably tell you how many sentences. So I can start building a way of systematically processing through blocks of information, through text, or through text files, or through content from a database, or through content from a website, and been able to, regardless of what the actual data is, process it in a systematic function. Step 1, step 2, step 3. Move on to the next block of data. Step 1, step 2, step 3. Move on to the next block of data. Step 1, step 2, step 3. And we keep going until we reach either a required amount or reach the end of the data. And those can vary from running to running of that program. But let's go back to conditional statements. Okay, so since we're near Halloween. When I was a child and I would go out and I'd go trick-or-treating, I clearly wasn't playing the game properly, because I would go around from house to house for however long I did, and I didn't really eat much of the sweets I got as I went around. And at the end of the night, myself and my brother would get our bags and pour them out on the kitchen table or on the floor or wherever we were doing it, and we'd look at the haul for that night. How much have we got? And my parents usually say, because again, trick-or-treating, it's done when it's reasonably dark, and trick-or-treating is done with young children. You can have one thing, and then you go to bed, and you can have the rest of it, or look at the rest of it over the next couple of days. If I was smarter, I should have been eating as I went. But there we go. And so I had a choice in front of me. I had this mound of sweets. I had to decide, well, I can only have one thing. What do I want? And if any of you have children, or you have seen a young child try to make a decision, we're presented with an awful lot of options. There's an element of panic that sets in. There's I want, and I can't decide, and it's kind of almost analysis paralysis. Kind of all these choices, which one could I possibly pick? But my favorite chocolate growing up was Aero. So I'd kind of go, oh, I want Aero. And if there was an Aero within that mound, and search through it, well, then I'd eat that, and the rest of it be put back in the bag, and the bag would be put out of reach of me. I'd eat the chocolate, I'd go to bed after some complaining, and I would then have the rest of it over the next couple of days. And that's essentially what a conditional statement is. When someone asks you, what do you want? They're asking you a question, and they're expecting a response. And that's what we want to do. We want to be able to check for values, check for conditions. Another great Irish one is, do you want your tea? Okay. And if it's a proper one, do you want tea? So they have to make the hand gestures as well. But if you're asking a question, and there's usually a response like, yes, I would, please, or no, thank you. We're going to start off with just the positive answer now. So, is there an Aero present? Yes, there is. Well, if there is an Aero present, I get to eat that chocolate bar. If there isn't an Aero present, I get nothing. Much complaining before I go to bed. And that's what we are going to replicate first. And of course, if this was, I learned a little bit faster than the way we're going to go through it now. But if this was the way I did it, then the next year I come up with an alternate option. If there's not an Aero, I want a Snickers or a marathon. If there's not an Aero or a marathon, well, then I want and I can have multiple options. And that's what we want to have a look at. So to simulate something like this in code, we would look at what's called an if statement. If the thing in the brackets is true, then I'm allowed to run the statement. If the thing in the brackets is false, I'm not allowed to run the bracket. I'm not allowed to run the statement. I have to skip it. And this is where we can add in this element of variance into our program. That I can write a piece of code that has an if statement or a series of if statements inside it, and I can give it to everyone in this class to run, and you will all run it slightly differently. And so you all will have different experiences of the code as you interact with it, depending on what your input is. we have this keyword if, and you'll see when you type it into code, and I'll do an example in a moment, that it is going to change color, signifying that it is one of those reserved keywords. You can't name a variable if, or a program if, or a method when you get to them if. So it's a reserved word in most programming languages, and usually it means if this, the thing inside the bracket, so if that's true, then this. Then you're allowed to do the statement. It's kind of a restriction. It's a condition. It's a bouncer for that section of code. Names not on the list, not getting in. The true-false expression is the proper name for it is a Boolean guard. But true-false expression, I suppose, is more descriptive. It is an expression of code, for example, count is less than or equal to 10, that will always resolve itself, will always simplify itself to either true or false. It's impossible for it to go to any other value but true or false. And that's really important to remember. Because as we start now, we start building up if statements now, and as we go further into first year programming, you get to the exam at the end of first year in May, and then you go on to second year programming, third year programming, you build your way through that. The idea of having a true-false expression as a barrier to entry to a section of code is really, really common, okay? You're going to have them in if statements, you're going to have them in loops, and there's a couple of other places where they appear as well. And you need to learn how to write these expressions. You need to learn how to create the correct logic, that it's a valid guard, so it makes sure that if you meet these criteria, you get access, but also that it is strong enough in its integrity that if you don't meet this criteria, or if you partially meet this criteria, that you don't get access. It's so important that for the last 9 years, part 1 of question 1 in every exam I write, that's both the May exam and the August repeat, is the exact same format. Not the exact same question, it's the exact same type of question. It is 5 English sentences that expect you to write a true-false piece of code to evaluate. So variable A is a number between 10 and 100. And you have to write a piece of code to do that. And the idea of it is that you can take that piece of code you've written and you can put it inside the brackets of an if statement, and you would only get inside this if it became true. So if variable A had a value of 11, obviously that's between 10 and 100, yes, you can get inside and you can go inside here. If variable A had a value of 9, no, you wouldn't be allowed in here. Or if variable A had a value greater than 100, you wouldn't get inside the if statement. That's what I'm looking for. Always part 1 of question 1. Always 5 questions. It's worth 10% of your exam paper. The ability to create these statements and to understand what's been asked of you and to correctly build the logic that can evaluate that is vital for your success moving forward in programming, both from an academic point and from industry, if you want to actually go out and end up working inside the industry as a programmer. So for the last 9 years, like I've just done now, I've told the first year class, this is what part 1 of question 1 is. It's 10% of your exam. You should be able to, in under 5 minutes, maybe 10 minutes, get 10% done of your exam. And then you only need, if you're worried about computer programming, you only need to worry about getting an additional 30% out of the 90 marks that are remaining. Okay? It's a nice kickstart into the exam. And every year, I get students who get question 1 wrong. And I don't mean, oh, they only get 8 out of 10. They get 0 out of 10. So if I might ask that question, variable A is great. Make sure that variable A is greater than 10, but less than 100. And they'll write down 55. Now you're laughing now. But in May or in August, depending on when you sit, if you don't get full marks on that question and you come back to go, I would like some feedback on my exam, don't be surprised if I'm quite tough on that first part of the question, saying, well, I told you this in week 5 of semester 1. We will do hundreds and hundreds of these Boolean guard statements. Every time we do an if statement, we're going to write one. Every time we do a loop, we're going to write one. Okay, so you will have a huge amount of experience on doing this. But this is the basic structure. We have our if statement here. We open up a normal round bracket, and inside this we put in our expression that we want to evaluate. If that evaluation comes back as true, well, then we're allowed inside the if statement. And you can see here I've got curly brackets around all of the code that I have. I only have one line here, but if I've got curly brackets, that's an entire block of code I can define. A really good example of how much code you can fit inside those curly brackets. Imagine I gave you a game as one of your assignments, and that game has got a menu. Press 1 to play the game. Press 2 to see the high scores. Press 3 to quit. So you press 1. If user input equals 1, and you've got all the code for the game. Could be 500 lines of code. Could be 1,000 lines of code, depending on which assignment it is. If user enters 2, show high score. Maybe you only have the last 5 or the top 5 scores, so you have 5 or 6 lines of code, not a lot. If user input equals 3, quit game. That's 1 line of code. So you can see that the amount of code we have inside these blocks, inside the curly braces, can vary. In the same way as we've seen, our programs have grown over time. They started off with 1 or 2 lines, and then they got larger and larger and larger, and that will continue as we go through first year. But the boundary, what you're allowed to do if this statement here is true, can be put inside these curly braces. And that guarantees that anything inside there will only be allowed to be run if this statement here is true. And if it's false, you'll immediately skip to the line below the closing bracket. That makes sense so far? Okay. And the positioning of your brackets is very important. I've got almost the exact same example twice on that slide. The top one opens my curly bracket here at the end of the if statement. That's correct. I've got 2 lines of printout statements. It says too few and then the word by. And then I've got my closing curly bracket here. If I ran this code and count had a value less than or equal to 10, so let's say the value of 5, in that scenario, it would print out too few, and then by, and then we'll assume that's the end of the program, it would stop. So you get 2 lines of output. If I had a value that was larger than 10, so let's say my value is 11, it would not print anything. Because it would come in and go, is 11 less than or equal to 10? No. Okay, down to here. And that probably is the end of the program. In the bottom example, I have the same guard on my loop. I open my curly bracket. I have the same printout statement. I close my curly bracket here, and then I have another statement below. In this scenario, if I entered in 5 as my value, 5 is less than or equal to 10, it would print too few, and then it would print by. But if I entered in 11 as my value for count, 11 is not less than or equal to 10, so it would not print anything inside here, but it would print by. So the positioning of your brackets can dictate the flow of your program. At the moment, the programs we're going to write are going to be tiny. The if statements we're going to build are going to be quite small. So it's worth your time now putting the effort in to pay attention to the positioning of your brackets and making sure that it's all correct. Because as we get bigger pieces of code and more challenging problems, you will see what's going to happen is that at nearly every year when I give out the first assignment, which is again about if statements and loops, and it involves an awful lot of curly brackets, there are students who come to me like, it's acting really weirdly, I don't know why. And they might have a random closing curly bracket somewhere in the middle of code that they shouldn't have. It was a typo, or they opened the curly bracket and because Notepad++ automatically closes it, it kind of got lost in between all of the lines of code they had. And because of that, it only does half of the work it's meant to do. Or it prints out things which are meant to be only accessible if you get inside this if statement, but because the closing bracket, it allows everybody to see the work printed out every time you run it. So just, if you pay attention to it now, like with the indentation, like with the way you write your code, the way you kind of use capital S here or capital S for string in the first part, it builds a habit. And it's a little bit of effort now when the programs are really small. So, oh yeah, I'm going to write it this way. But the more you do it, the more habitual it becomes, which means the easier it is not to have to think about it when you're stressing out about what's this assignment meant to do or how I'm meant to solve that problem. It's one less thing to worry about. I don't need to worry about my indentation. I don't need to worry about how I've named variables. I don't need to worry about how I've presented my comments. They're things that I've been practicing. So it's only the actual problem of the assignment I'm worrying about. Okay, here's another example. Here's a full example here. So we got class conditional 1, both side void main. We create a variable here called x, and we give it a value of 2. And our check here is to see if x is greater than 0. So what's going to happen in this scenario is when we use our variables, and we actually, not when we initialize it, but when we use the variable, the program does something called the substitution rule. It simplifies that. It looks at it and goes, x greater than 0. Oh, x is a numerical value. So I'm going to take, wherever I say x, and I'm going to swap it for the current value inside there. So it goes off to memory, it retrieves the value, and then it becomes 2 is greater than 0. And then you have a nice equation. You have a comparison operator, the greater than symbol, and you've got two numbers either side. That's something I can simplify. Is 2 bigger than 0? Yes. Okay, super. Well, then I can replace this entire statement with the word true. And if the word true is in here, I'm allowed in here. So when you run this code, it will print out positive because x is a positive number. Okay, so I'm going to hop out of the code now for a moment. And we are going to build that again. I'm lazy to begin with. I copy that. Oh, I don't need to. I'm actually going to expand it a little bit and use user input so we can test this. 0 to begin with. System out print. And then number. We have x is equal to kb.next. Okay, so up to now, nothing new. This is all the things we've looked at up until today in the class. What I'm going to do now is I'm going to have an evaluation. So I'm going to say if x is greater than 0, open my curly brackets, and here I'm going to say system dot out dot print and then positive. Okay. So now I've got a piece of code that allows the user to enter a number, and I can categorize what that number is. So command prompt, my desktop. Here I can go Java C conditional. No errors, that's good. Java conditional. Please enter a number. If I enter in 23, that's a positive number. Super. If I enter in minus 12, it doesn't print out anything. Now it doesn't print it. We know that minus 12 is a negative number, but it doesn't print out anything. Because if you look at my code, I only have one option in my question. Is this if it's greater than 0, print out positive. When you're categorizing numbers, there are three categories. There's positive, greater than 0. There's negative, less than 0, and then there's the number 0 itself, which technically isn't positive or negative. So we've only got one of those options now. And like with my Halloween example, if my option isn't there, if the option that I want isn't there, I'm probably going to ask for an alternative. So someone likes time bars. Okay, so first option is if there is a arrow, I'll eat the arrow. Otherwise, I'll have a dime bar. Okay, so this is my contingency. I want this. If I don't have this, I suppose I'll have this. We want to be able to replicate that in code. So again, we think of our numbers. If the number is greater than 0, it's positive. Otherwise, it's negative. And then we're going to add in the third way of saying, well, actually, it's not positive or negative, then it must be 0. So it's a slight extension of what we have. We add an else. Okay? So again, in an English statement, if this, then this, otherwise this. Have any of you ever used the app on your phone, if this, then that? Okay, so it's a way of setting up patterns on your phone. I had one when I was trying to track how many hours I was doing in here, that I'd have, if my location equals Griffith, then add note in calendar. If my location does not equal Griffith, then add left Griffith on my calendar. So I could basically track my work hours and how many hours a week I'm on campus. But it's the same idea. It's if doorbell rings, answer door. Otherwise, continue watching TV. It's that type of scenario. So again, we have one expression up here. We're only asking one question. Okay? And if that question resolves itself to true, then we're going to run statement 1. Otherwise, if it resolves itself to false, which is the only other option we have, we're going to run statement number 2. So for example, here in this piece of code, if count is less than or equal to 10, we're going to print out too few. Otherwise, so if it's 11 or greater, we're going to print out enough. And either way, whether we print out statement 2 or statement 1, we're going to print out by at the bottom. So the difference between this and the previous example where we didn't have our else is that we have this new block down here, our alternate. But note that the alternate doesn't have a condition beside it. It just says the word else, and then we open up a curly bracket. And the reason for that is because that's what it is, your alternate. If all the other options fail, just do this one. Okay? It's your fail-safe as such. So this is what you're going to check for. This is what you want. If you get this, fantastic. You're going to run this piece of code here. If you get into this block of code here, when you hit the closing bracket, you skip everything else. So you skip the else part or any other parts we're going to link in. And you go down to the by printout statement. If you don't match statement 1 or question 1, so count as a value of 11, which is not less than or equal to 10, well then you don't get into this line of code, but you do get into here, and you run enough, and then you print out by. In both options, you only get to run one of the statements, either statement 1 or statement 2. There is no scenario where you get to run both statement 1 and statement 2. If you have written a piece of code where it seems like you're running all of your options, there's something wrong with the way you structured your code. Okay? And we'll look at how that can happen later on. We've covered all the options that we have here. But if you have code like this, where you've got an if keyword, you've got your statement to evaluate, you've got your curly blocks with curly brackets, with some section of code in there, you've got your else keyword, you've got your curly brackets, and you've got another section of code here. It is impossible to get the program to run both of them in one go. It will do one or it will do the other. It will never do both. Does that make sense? Do you guys have any questions at this point? Okay, let's go and expand our question that we were doing. So we have now that if it's greater than 0, it's positive. So we are going to add an else statement. And again, you can see that else comes up in a bold font. So again, it highlights it's a reserved keyword. We're going to open our curly braces. And we're going to have system.out.print and then negative. Save it. Right, okay, so let's go into our command prompt. We're going to recompile because we've edited the code. And we're going to run it again. If we enter a number now, if we enter in 12, it still comes up as positive. If I enter in -4, it now comes up as negative. So I have a way of categorizing those other numbers. Okay. Now, my code here is pretty simple. I only have one line in each statement. And in my slides, I have the same. I only have one line in each statement. But you're not restricted to that. You can have as much as you want. And when you start adding in extra content, you get this idea here of compound statements. So it's a block. It's not just a statement, or it's not just a one command you're running. You could be running a whole bunch of commands together. And what will happen is, because you have encased all of the commands you want to run inside your curly brackets, it'll just process through them one after the other until it hits the bottom. It hits the curly bracket at the bottom. So in this example here, I'm checking to see if x is less than or equal to 70. If it is, I'm going to print out incrementing x, and I'm going to run this command here, which now seeing it, I realize that's something I usually reserve for loops, but what x plus plus means is increase the value of that variable by 1. Okay, so whenever you see a plus plus, it means increase by 1, and in the same sense, whenever you see a minus minus, it means decrement, decrease by 1. When we get to loops next week, you'll see that this is incredibly common. It's shorthand for sitting. It's a short way of writing x is equal to x plus 1 or x is equal to x minus 1. And it's such a common task inside programming of you have a whole bunch of things to process through. So you start at 1, and then you go 2, and then you go 3, and then you go 4, and then you go 5. That the plus plus and minus minus have become really common for traversing content. Yes?
It's probably a dumb question, but why wouldn't they just put x plus 1 or x minus 1 then, or what makes it
It's a good question. I don't know. My assumption is that the increment of just 1 is so common that that's got the special shorthand. However, if you want an increment by 2 or by 15 or by some varying amount of number, that's where you'd have x is equal to x plus whatever that value is. And so if you have something beyond the most common one, you write it out longhand. Now, I say longhand, it's 4 extra characters. But you understand, like, the shorthand is considered to be, well, that's the simplest way of writing a loop. When we get to, we're going to look at 2 types of loops this year. We're going to look at one called while loop, and then we're going to look at ones called for loops. And when you see for loops, you will see that the x plus plus is kind of an integral part of that. Any other questions? Okay, so this piece of code evaluates the value of x. If it's less than or equal to 70, it's going to print out incrementing x, and it's going to increase the value of x by 1. Otherwise, in other words, if it's larger than 70, it's going to print out decrementing x, and it's going to decrease the value of x by 1. And in both scenarios, after it's either incremented or decremented the value, it's going to print out the word by. So the bracket positioning here is important. If I move this bracket up to here, that would actually cause a compile error. Because what would happen is you would get the if question, if x is less than or equal to 70, you'd open your bracket, you've got your printout statement, you close your bracket, and then it gets any command that is not an else or the next thing we'll look at, which is an else if. And so it assumes that, well, that's the end of that question. There was only one option there. And if we match the option, great, and if we didn't, we'll just move on with the rest of the code. So when it comes across an else, and it's not linked to an if, it's going to cause a compile error. I suppose the best way to show you that is to actually run the code like that. Okay, so new. Cross. Sure, that gets 8 more units. I'll tidy up the indentation in one moment. So all that should go in here. Oh, well, very important. There's going to be an issue with this code. I need to show you in a second. Okay. So again, in my slides, I was giving you a sample of code to get this to work. Well, I haven't got a variable x, so I need to declare that first. So I need to say int x is equal to, and I need to give it a value, let's say 55. Okay. Let's very quickly just run this code to make sure it's working. So Java C, conditionals. Okay, and then Java. Okay, incrementing x and y. Now, we never print out the value of x, we just tell the user, hey, we're incrementing the value, and we finish from there. If I was to move this bracket, delete it off line 7, and put it here, that's going to cause an error, because this is considered to be the end of the question. This is not part of the if-else structure. So this is something separate. This is after the question, this is the rest of the program. And then it's going to get to this. And the error we're going to get is probably something along the lines of an else statement without an if. We have broken the link between these two. If I put that back the way it was, the fact that the closing bracket of the if statement is here, and the next character that we see is the start of the word else, creates a link between those two parts. And that's why it becomes option A or option B. But if I put it back like this, well, now I only have option A, and this is going to be treated as an entirely separate question. However, that's not how you start asking a question. So if I save this now and go back and I run it, I'm going to get this error, an else without an if. It's an orphan else. It does the way these statements work, the very first part of them, no matter what they're doing, no matter how many options you have, and you're going to see the next thing we're going to do is how do we add in more than 2 options? What if we want 20 options? One of the questions in your worksheet is months of the year, and that's an if statement question. So you're going to have an if for January. So if month equals 1, then print out January. You're going to have 11 other options, and then you're going to have an else at the bottom, which is going to be, well, if they didn't enter in 1 through 12, tell them that they entered the wrong number. And they're all linked. That's one question with multiple options that you're going to pick from. As soon as you insert some code in between the closing bracket of one section and the keyword starting of the next section, it breaks those links. And that's where we can get these errors. Now, the errors are usually pretty descriptive, so an else without an if, that's pretty obvious what's happened. But again, this is a really small program, so it's really easy to look at it and go, oh, this should be up a line. But when you have a 500-line piece of code, a 700-line piece of code, a 5,000-line piece of code, you're slowly scrolling up and down to figure out, what have I deleted? Where have I moved a line of text? How did that happen? That can take hours, depending on how complex the code is. It's a really good demonstration of why it's really important to have your brackets matching always. And what I mean by that is if you open up a bracket, if it isn't set up automatically, on my Notepad++, it's set up automatically. As soon as I open a bracket, it automatically closes it for me. And if you don't have that set up, start typing that closing bracket. Because having the brackets, even if your indentation is off, and we'll come back to that probably next week and talk about indentation, or maybe this week. But even if your indentation is off, as long as you have the correct amount of opening brackets and the matching amount of opening brackets to closing brackets, your code's probably going to work. If you have the same amount of opening brackets and closing brackets and your code isn't working, it's probably because of the position of the brackets. We might have moved one up a line when we shouldn't have. But brackets can massively alter what happens in a program and in what order it happens. And remember, a program is an ordered list. It's an ordered list of instructions. So as soon as I start editing the code or mistyping the code to alter that order, my program won't act as expected. Okay? It won't do the things I want in the way that I want them. This is absolutely fine. See where I've got an extra space in between this closing bracket here and the start word else, because there's nothing in between there. If I put a comment in there, that's absolutely fine as well. So I could put a comment in here that says incrementing, and I can put a comment in here that says decrementing. That's absolutely fine. because the comments aren't usable pieces of code. They're stripped out when we go to build this, when we run our JavaC command. All of this white space here is stripped out when we go to run our JavaC command, because the computer doesn't need it. If you're in the way we write our code now, with our indentations and with comments and moving on to a new line, is for us, it's for the programmer to go, oh, I can read that piece of code. If everything was on one line with no word wrapping, it would be really difficult to work out what's happening. This is for our benefit. So from a functional point of view, line 10 gets stripped out, line 9 gets stripped out as well. So it'll shrink itself up to what it was, like that, and it'll run forward in that sense. Okay. Save that there. Let's go back to our slides. There's only 18 slides in this, so I'm going to keep flipping back out and into code as I'm working through. Here's our negative example, but we've already done that one. So I'm going to move on from that. Okay. More chocolate. So again, let's assume that well, clearly I wasn't a smart child if I didn't eat chocolate going around. Let's say I really wasn't a smart child. In the first year I went trick-or-treating, my friend said, what do you want? I want an arrow. Well, there are none. Go to bed. So the second year I learned. What do you want? I want an arrow or I want a dime bar. I want an arrow if they have one. If they don't have an arrow, I want a dime bar. And maybe that year there wasn't an arrow or a dime bar in there. So the third year I came back and I've got multiple options. I want an arrow, or I want a crunchy, or I want a dime bar. Okay, so I'm slowly learning. I'm slowly expanding my options that are here. And we can add in this middle section, this third option. And we do this by using an additional command. It's kind of a combination of the two we've seen already. It's else if. And so what you're doing now is you're giving, initially we had what we want, and we had if all else fails. What we're adding in now is what we want, our second choice, maybe our third choice, maybe our fourth, fifth, seventh, eighth, ninth, 200th choice, and then at the very bottom, if all else fails. And because we can do that, we can have a really wide-ranging scope of what our if statement can look at. So think about your month of the year question. That will take in 12 possible options. You're dealing with integer numbers, so it's 12 out of 4.2 billion. Or 4.8 billion, sorry. But it's 12 numbers you're going to enumerate through. If it's 1, do this. If it's 2, do this, up to 12. If it's anything else, if it's 0 down to minus 2.4 billion, or if it's 13 up to positive 2.4 billion, you're going to drop to the else category. I've gone through all my possible options. Everything else, do this. Do the bottom one. So let's look at how we can do this. And we're back to this type of statement here. I don't know why I set that. We have our if statement that's got our true-false expression. If that expression is true, we're allowed run statement 1. We have at the bottom our else statement. If we get to here, we automatically run statement 3. And if we get down to here, it guarantees that nothing above matched. We weren't able to find a true result for any of them. And in the middle, we have our else if statement, which also has a true-false expression. So for the else if keywords, you can add in additional evaluations. Okay, so the first one is, if chocolate bar equals arrow, then eat arrow. Else if chocolate bar equals crunchy, eat crunchy. Else if chocolate bar equals dime, chocolate bar equals, you can iterate through all the ones you can think of, or all the ones you might have there. Otherwise, go to bed hungry. And that's what we have now. This is the full extent, or the full features that we have inside our conditional statements. We have an if statement. It's always at the top. It's always the first part of the question that you're asking. It always has a condition. It always has a true-false expression that needs to be evaluated. In the middle, we can have an else if statement if we want. We can have anywhere between 0 and infinity else if statements. We don't have to have them, but we can have as many as we feel we need are suitable for the question. And every one of those else if statements has an evaluation behind it, has a true-false statement that needs to be evaluated. At the very bottom, we have an else statement. Again, we don't need an else statement. But if we have one, we can only ever have one. So it's somewhere between 0 and 1 else statements per question you're going to ask. So let's return back to our, let's have a look at an example here, and then we'll turn back to our numbers to categorize if it's not positive or it's not negative. So here what we have is we have our if statement with our evaluation. If count is less than or equal to 10, we're going to print out too few. Otherwise, if count is greater than 15, we're going to print out too much. And if it doesn't match either of those two, well then we are going to print out enough. And regardless of where it finds it can go into, it's always going to print out bottom. Just like with the previous example, we will only ever be allowed to run one of these options. The first one that it finds that it's valid for, it'll run that and skip right to the bottom. So imagine we have 200 options in our question. It's a really big question. It'll start at the top, at the if statement, and it'll work its way down in that order, which also highlights that the order you write the code for this is important. You write it in order of preference. Your first choice, your second choice, your third choice, and so on. If you do it out of order, it's going to stop at the one it matches first. So if it matches your 15th choice, but that happened to be written in your second position, it's considered, well, that must be your second choice, and it does that. As soon as it finds one that matches, so let's say it gets the else if, its value is 16. It goes in here, it prints out too much, and it immediately jumps to the bottom of that block of code. It skips any other else ifs that might be below it, and it skips the else, because I can only ever run one of these options. Does that make sense? Okay.
Is there a way to assign a hierarchy to it without having to write it in order of preference?
No. The whole, well, technically writing it in order of preference is defining your hierarchy. Right. Oh, this done first, then this, then this, then this, then this. So that is building your hierarchy. And for a true hierarchy, where we've got different subsections, we will actually get onto how you can put a if statement inside an if statement, inside an if statement, inside an if statement. And you can build a true hierarchy where you've got all these layers of questions. But no, if you want to build your order of preference, it's how you write the code. This is building your order of preference here. So for example, in the months of the year question, logic would dictate you do January 1st, then you do February, then you do March, and so on. And because you're linking it to the months of the year. You don't have to. In that specific question, you can write them backwards. You can write them by the number of characters in the word. It doesn't really matter because it'll only match one of them. But if you want to maybe do different actions in your program, if you read the guessing game question, the last question on your worksheet, that game will keep running until the user guesses the number correctly, or the user has exceeded 20 goes, or the user chooses to quit the game by entering a negative number. They are all true-false expressions. Have they guessed the right number? Yes or no? Have they had more than 20 goes? Yes or no? Have they entered in a negative number? Yes or no? And so what you're doing is you're checking each of those three criteria every time you get them to make another guess, which is what we're going to look at how to do next. Okay. So let's go back to our number example here. Okay, so we have our positive here, and we have our negative. So let's go else if x is less than 0. We're going to print out negative. And then we have our otherwise. Else zero. That should be there. That should be there. And now we've utilized this question fully. We can categorize any number. We can say if it's greater than 0, it's definitely positive. If it's less than 0, it's definitely negative. And if it's not greater than 0 or it's not less than 0, well, that leaves a single number out of 4.8 billion. It means it's 0. So if we save this, go to our command line, build it, run it, enter a number, so enter 12, tells me it's positive. Run it again, enter in -9, tells it's negative. Run it again, enter in 0, tells me it's 0. So it's going then through all of our possible options. Is it greater than 0? No. Okay. Is it less than 0? No. Okay. Well, then the only other option is it's going to be 0. In these questions here, we have comparison operators. So we have arithmetic operators we've looked at already. We have addition, subtraction, multiplication, division. And then we have modulus for integers. So you remember that we have division. And if you use the div command on an integer, we're only dealing with whole numbers. It'll tell you how many times it goes in evenly and ignore whatever's left over, the fractional element of it. But to deal with the fractional element, we have the percent sign, the modulus command, which will give us the remainder. It ignores how many times it's gone evenly, and it says there is 1 left over, or 4 left over, whatever it might be. The other type of operators we have here are our comparison operators. And we have 6 of them. We have greater than, less than, greater than or equal to, less than or equal to, equals, and that means the left-hand side is the exact same as the right-hand side. And then we have not equals. The exclamation point, or sometimes the program is called bang, can be used to implicate not, or if you put it around a statement. So for example, if you had the statement true, and you put that in front of it, it would negate it. The same way it does it in computer hardware, your truth tables, that it's negating whatever the value is inside that, so it reverts it. And clearly, the negate command only works with Boolean commands. It will not work on 2 plus 2, and you can't go not 2 plus 2. Because it's simplified to 4, not 4 is nonsense. So there are our operators that we have. The first 4 we've all seen before in math. So most people are absolutely happy with them. There isn't an issue at all. This one here is probably the tricky one, and it's only tricky because this is a comparison, an equality comparison. It's the left-hand side identical to the right-hand side. If we use this statement here, we might have something that says like 2 plus 2, not an underscore. And remember, when we're using any of these 6 operators, the outcome can only ever be true or false. So 2 plus 2 is 4, yes. Because if I simplify this, I get 4, and then I get 4 is the same as 4. Yes, 4 is the same as 4. That's absolutely correct. Whereas if I did that, well, that will 2 plus 1 will simplify to 3. Is 3 the same as 4? No, it isn't. So it'll come back as false. Does that make sense? Okay.
No,
This one here with is it this bit here that comes, does this make sense? Or all of the operators? Yes, I'll go through it again, no problem at all. Okay, so the first one here is going to be greater than. So let me see if I can format this a little bit so it makes sense. Okay, so here we're going to say positive and negative. Here, so we could have 5 is greater than 2. That's going to resolve itself to true. Whereas if we had -4 is greater than 2, also, that's going to resolve itself to false, because -4 is not bigger than 2. Here we can have 6 is less than 9. That's going to come out as true. That's absolutely fine. And here we're going to have 9 is less than 1. That's going to come out as false. That isn't there. This is kind of the same thing, but what we can have is we can have 6 is greater than or equal to 6. And that will come out as true, because it's not 6 is not greater than 6, but 6 is equal to 6. And here we would have 5 is greater than or equal to 6, come out as false. And the same we have for this. So that works fine. And here, if we had 9 is less than or equal to 6, wouldn't work. For this one here, that works, that's fine. And here we could say, well, that's false. We know that's false. 6 is not the same as. Whereas here, what we can do is we can say 6 is not equal to 7. That is true. They are not the same. And here we can have the calculation that I have here, which is going to be 2 plus 2 is not equal to 4. That would come out as false because clearly they are the same, and saying that they're not the same is a false statement. Okay. So these type of comparison operators we usually use on numerical data types, integers and doubles, because it's very easy to have a look at them. The interesting thing is when we're dealing with characters, which we're going to look at in 4 weeks' time, because the assignment week's going to come up. So next week's loops, the week after that will be strings, the week after that will be assignment week, I believe, and then the week after that will come back to characters. Everything you see on the computer, if you see a 5, or if you see a O, or if you see a exclamation point, that all reverts back to some numerical code in the operating system. The operating system, the computer, does not understand letters or symbols innately. It only understands numbers. And so what they've done is they've created something called the ASCII table, which is a numerical lookup table. So if I type in a plus symbol, it'll go back up and go, oh, that is code 75, or whatever it may be. It's not 75, that's what I'm thinking of. Or if I type in 2, it'll go back up and it'll look up specifically what that numerical code is. And when we are dealing with characters, so any single key that you can type on the keyboard, we can actually treat them as if they were numbers. We can say that A is less than B, because when they go back and they have a look at where they appear in that ASCII table, in the lookup table, A happens before B. The numerical code for A is lower than the numerical code for B. But we'll come back to that in a couple of weeks' time. Okay. Okay, we've already done that one. Now, okay, so the next thing, the last chocolate example I'm going to use, I think, at least in this lecture, is going to be nested if statements. So a nesting statement is where you put the same type of statement. So you have one if statement and it opens the curly brackets, and inside those curly brackets you put another if statement. So where's a good example? I'm assuming at some point everybody here has gone to a coffee shop and ordered a coffee. Let's say it is Starbucks. That's a nice easy one to go with. Okay, so you go up to Starbucks and you say what coffee you want, or they ask you what coffee you want, and you give them the details they need. I want a cappuccino grande or grande cappuccino. So then they kind of go, oh, do you want that? Or actually, I know it. I can never remember my wife's coffee, and she always texts me. Hang on, what was the last one that she texted me? It was a hazelnut latte. Right, okay. So, I'm also realizing this is on the YouTube. Right, this is going to be great. So when you go, I go up to the counter and I go, can I get a grande hazelnut latte, please? So they go, okay. So the first thing is I've given them in the if statement what coffee I want. So they've gone for a particular selection there. And then when they've asked that and they say, oh, there's a syrup involved in that, they always ask me, do you want sugar-free? So that question is only asked if I get into an option where there's a syrup. If I just say I want an Americano, they never ask do I want it sugar-free, because by its nature it is sugar-free. But if you add a syrup to it, there's two options of that. And then they ask, do you want a skinny or non-skinny coffee? You only get those when there's the opportunity to add milk while you're making the coffee. Again, if you ask for an Americano, just a black coffee, you don't get it. You get the black coffee. If you ask for a cappuccino or a latte, for any of the ones that have milk involved in it, they say, do you want skinny or do you want non-skinny? And then they usually ask, do you want whipped cream? So there's sub-questions. If you get past the first question, then they have follow-up questions. But you only get to those when you get into the when you get into past the first question. So let's imagine that I had one really lucky Halloween when I was a kid. I had the hall chocolate, and they go, what do you want? I want an arrow. All right, what arrow do you want? And there's options. Okay, so yes, you can have an arrow, but do you want an Irish cream arrow, or do you want a mint arrow, or do you want a sticky toffee arrow? And so that question, that sub-question, is only asked if you get past this first one here. It's hidden inside the curly braces of this block here. And it doesn't make logical sense to ask this follow-up question if this one comes back as false. Does that make sense? It would be like going into, let's see, it would be like going into a shop to buy a laptop, and you go, oh, I want to buy an Apple. And they go, we don't sell apples. And then you go, I want to get a MacBook Air. The follow-up statement is irrelevant because they've already said to you, we don't have that. So you saying, well, I want this specific model of that MacBook, doesn't make sense because they're still going to say, well, we still don't have it. And that's what we're looking at here. So how we would do that is this example. Now I'm going to build a better example for you after the break. We're just going to work through some examples. But here we have two variables. We have variable x and we have variable y. If variable x is equal to 3, so that means that x has the value of 3, well then we can ask the follow-up question, does y have the value of 5? If x has the value of 3 and y is the value of 5, I get to go into this set of curly braces here where I'll print out the word apple. If x has the value of 3, but y does not have the value of 5, I get to go into this curly brace here that prints out the word pear. This else statement here is linked with this if statement. If you look at the indentation, this curly bracket matches up with here, this curly bracket matches with here, and then we keep the else implied as well. So your else statement will always match with the closest if statement you can find, which in this example here is this one and not this one up here. But being able to do that allows a huge amount of opportunities for us, because now we can ask follow-up questions, ask sub-questions, and get a really detailed answer. So rather than saying, again, do you want a coffee, yes or no, we can now ask that question, and if we get a yes response, well then we can ask a series of follow-up questions to have not just a coffee, but to have a really specific coffee. Does that make sense? But we wouldn't ask any of those specific questions if they said no. So kind of it skips that whole block of code. Okay. I'm going to skip that slide, and I'm going to skip that slide because I'm going to come back to it. So we're going to take a break in a couple of minutes, but I just want to recap quickly what we've done, and I'll recap or highlight what we're going to do after the break. We've looked at today the ability to ask questions of our programs, which means that our programs can now act in different ways depending on what value has been entered into that equation, to that question. And this allows for variance in our programs. It means that one person can run a program 10 times and we can go and it can act differently in each of those 10 times. If we're going to ask a question, we always start off with the keyword if, and then we have brackets, and inside those brackets are going to be a statement we need to evaluate, a Boolean expression. And the Boolean expression will only ever respond with a true or with a false. So we need to make sure that whatever we write inside those brackets can be simplified to true or false. Now, based on what is inside the brackets, so for example, conditions 1 here, so this one here, the chances of it being coming out as true or as false, in this case here, depends on the value of x. And that's where the uncertainty comes into these programs. It's dependent on what that variable is. So if you're looking for them to enter a specific menu number, so enter 1 to play a game, enter 2 to view high score, enter 3 to quit, the value of their user input is going to dictate which one of those options you're going to go for. Speaking of options, if we want more than just one question and one possible option, we can create further options underneath by using a combination of else. If we only have 2 options, we have if and we have else, Or if we have more than two options, we're going to have if, else if, and else. When we're dealing with an if, else if, and else, the if statement must have a Boolean expression here. Any of the else if statements or all of the else if statements must also have a Boolean expression, but else doesn't. It's kind of your fail safe. If everything else above has come back negative, just do this instead. When we're building our questions, we only ever have one if statement. We can have somewhere between 0 and infinity else if statements. We can have as many as we need for that question. And we don't have to have an else statement, but if we do want an else statement, we can have at maximum, we can have one else statement. So you have to have one, and you can only ever have one if statement in any one question. You don't have to have an else if statement, but you can have as many of them as you feel is necessary to solve the problem. And you don't have to have an else statement, but if you want an else statement, you can only have at maximum one. And the last thing we looked at was once you have created your block of code here, which is going to be defined by our curly brackets, inside that, we can have follow-up questions. We can have nested questions. So we can put an if statement, another question inside a question, and we can put another question inside that, and another question inside that. And we can, because of the chain of questions we can build up, depending on the answers that are given, we can have quite detailed analysis of what's happening and how the user has interacted with our program. After the break, we are going to do some worked examples. I'm going to do 4 or 5 examples with you and bring you through the code to show you how it works. But we're also going to look at the idea of logic gates or logic connectors and how we can use them. So in computer hardware, you would have already at this point looked at an AND gate and an OR gate. So an AND gate means all of the options in that AND gate need to be true for the outcome to be true. And an OR gate is if any of the options are true, the entire statement is true. And we can incorporate them into our Boolean expressions here to make more complicated questions where we're asking a whole series of things. The valid date question in your workbook by entering a day and a month and a year and doing some analysis on that. That will use logical ANDs and logical ORs to build up a complex equation on how we're going to say, yes, there is only 30 days in September and that's a valid year, or no, there isn't 31 days in February, even in a leap year. Okay? It is now 7:45. We're going to take a 20-minute break. We'll come back at about 8:05 and we'll look at the rest of it.